Now up, Chapter 12, Solutions. Solutions are homogeneous mixtures, which if you remember means they are uniform throughout. See the Kool-Aid guy up there in the corner? Kool-Aid is an example of a solution. Also, the term soluble means it's able to dissolve. So when sugar dissolves in water, we say that sugar is soluble in water. As you remember from middle school, there are two components to a solution. The solvent is the dissolving medium. So what's doing the dissolving? Water is considered the universal solvent because it can dissolve so many things. The second component of a solution is the solute, and this is what is being dissolved. Sugar and tea, one of my favorites. If you're mixing two liquids together, then the solute would be the substance that's in the lesser amount. I think I'm going to have a cup of tea. You can make solutions out of all three types of matter, solid, liquids, or gases. Liquid solutions are what we normally think of. That's your Kool-Aid. Gaseous solution would be like the atmosphere, a mixture of gases. And solid solution would be an example, would be an alloy, a mixture of different metals. Solutions are everywhere. If you remember from earlier, an electrolyte is a solution that can conduct electricity. Remember the light bulb? These occur when you have ionic compounds as your solute, because ionic compounds would dissociate into ions, and you need the ions to conduct an electric current. Suspensions are different from solutions in the fact that the particles are really large and they're going to settle out over time. They're heterogeneous. We can see the particles, and if you leave them set, they're going to settle out, and we can also filter them. Large particles. A colloid is somewhere in between a solution and a suspension. The particles are larger than a solution, but they're not large enough that they're going to settle out over time. The random motion of the solvent molecules, kinetic molecular theory, is enough to keep the colloid particles suspended within the solvent. It's not going to settle out over time. Milk and mayonnaise are examples of colloids. Ew. The two parts to a colloid are called the disperse phase. Those are the colloidal particles, and also the dispersing medium. That is the substance in which the particles are suspended. Here's a lovely representation of the differences in sizes between the particles of a solution, a colloid, and a suspension. In a solution, the particles are so small you're not able to see them. In a colloid, the particles are small enough to stay suspended within the medium, but you can see them, often look cloudy. In a suspension, the particles are so large they're going to settle out over time. There are different types of colloids or emulsions. A liquid emulsion is when you have a liquid dispersed in a liquid, milk or mayonnaise. A foam is when you have a gas dispersed into a liquid. That'd be like sea foam. And then also a solid emulsion, which is my favorite because chocolate is an example of a solid emulsion where you have a solid dispersed in a solid. Sea foam. This is a very cool picture of sea foam off the beach in Sydney, Australia. This is from about 2007. There was a large storm that was offshore that was really churning up the water, and because of an algal bloom they were having, they was picking up, the algae allowed the water to be more attracted to the air and mixed everything together. I don't think I would be swimming in that though. This boy is nuts. I'm sure you'll remember the saying like dissolves like, and remember polar compounds will dissolve other polar compounds and also ionic compounds. The opposite charges allows them to be attracted to each other. Nonpolar substances will dissolve other nonpolar substances. This is because they have very weak intermolecular forces, and so they don't block each other out. They just randomly mix because of the motion of the molecules. They can slip in between each other. Things that cannot dissolve in each other or will not mix are considered immiscible. In general, that's because something is nonpolar versus polar. The polarity of the solvent is not going to let the nonpolar molecules slip in between their strong intermolecular forces. Two things that will mix together are considered miscible. So alcohol and water are miscible, while oil and water are immiscible. Now, if you remember, anytime there is a change, whether physical or chemical, there's going to be an energy change. Same thing, we're dissolving things in a solution. We're dissolving a solute into a solvent. We call these enthalpies of solution. They either absorb heat, takes heat to dissolve, or it will release heat as the dissolution process is taking place, endothermic or exothermic. The numbers have values to them, and those values you can find them in your book if you want to look them up. But if the value is positive, that means that the system absorbed energy, energy was taken in. If the value is negative, that means energy was going to be released. Just like our Q problems that we did a couple chapters ago. One way to distinguish between a solution and a colloid is the Tyndall effect. Colloidal particles are large enough to scatter light. And so when a beam of light, like in this picture up here, is shining through a colloid, the light particles get scattered and you see a nice beam of light that's shining through. Very similar to headlights shining through fog.